What is an off-by-one error in algorithm implementation? Imagine writing a program to count how many items are in a list, but somehow it ends up missing the last item or counting one too many. That's often caused by an off-by-one error. It's a common mistake programmers make when working with loops and arrays. An off-by-one error happens when a value, like a loop counter or an array index, is set incorrectly by just one. It might be one too high or one too low. This small mistake can cause the loop to run one extra time or not enough times. It can also make your program try to access data outside the valid range of an array. For example, if you have an array with 10 elements numbered from 0 to 9, and your loop runs from 0 to 10, it will try to access the element at position 10, which doesn't exist. This can cause errors or unexpected behavior. On the other hand, if your loop stops at 8 instead of 9, it will skip the last element. A classic example of this is the fence post problem. If a fence has 10 sections, it actually has 11 posts. Counting posts and sections can confuse people, leading to off-by-one mistakes. These errors are tricky because the program might still run without crashing, but it produces wrong results. They are especially common in languages like Python, Java, and C, where counting starts at 0. When you forget whether your counting starts at 0 or 1, it's easy to make a mistake. To avoid these errors, it's best to clearly define your start and end points for loops. Use half-open intervals, meaning include the start but exclude the end. Make sure your comparison operators are correct. For example, use less than rather than less than or equal to when appropriate. Doing dry runs or tracing your loops on paper can help catch mistakes before you run the code. Also, include boundary cases in your testing to see if your loops process all intended elements. By paying close attention to how you set your loop limits and understanding array boundaries, you can prevent off-by-one errors. Fixing these mistakes makes your code more reliable and your algorithms work as expected.